Good afternoon, grade 12s. Welcome to mathematics. Today we are going to be focusing on paper 2 revision. Remember that the learners of doing grade 12, they had to write or rewrite this question paper due to what happened with the question paper that they wrote. That was written on the 16th last month. But before we can start with the revision for today's lesson, I just want to give advice to the grade 12s who are doing mathematics. And now the first advice is that please let us make sure that when we are revising, we are using the previous question paper. And then secondly, make sure that you do have examination guideline for mathematics. It's a very, very important document. Then you can just go through that document and look on the topic for paper 2, because remember we have done with paper 1. We are now have to rewrite paper 2, and then just go through that document and then look into the topic that falls under paper 2. And then there's this topic which is very important, which is Euclidean geometry, because they outline the acceptable reasons that you have to give when you are giving the statement. Because a statement without the reason, remember, you are not going to get a mark or get full marks. So let us make sure we go and revise those acceptable reasons, all right? And then let's proceed and see what are we going to be revising. All right. As I was saying, that we are going to be focusing only on the revision for paper 2. So I've tried to give us the picture of this paper 2. Remember, it is written out of 150 and then it's for 3 hours. And then I'm going to give you the weightings of each topic that falls under paper 2. The first topic that we're going to be discussing is statistics, which is giving us 20 plus or minus 3 marks. And then we go to analytical geometry, which is contributing 40 plus or minus 3 marks. And then the third topic, which is trigonometry, which is weighting 40 plus or minus 3. And of course, the last one, which is Euclidean geometry, which is 50 plus or minus 3. So in total, it gives us 150. And then we also have to be able to know how much time we should spend on each topic when we are answering. It's very, very important. But that one, I will explain it later. How best can you manage your time so that by that 3 hours is finished, you are done with everything. All right, because that is the challenge with majority of learners. When they have to write mathematics, you'll find that they are not be able to complete all the questions in 3 hours. All right. Okay. Now today we are going to be focusing mainly on what? Statistics. And then remember, statistics, when you go to question paper, it is question 1 and question 2. All right. Then we'll be revising the question paper that we wrote on the 16th of last month, and then compare it with the question paper of last year, 2019, November, paper 2, and then look into those 2 questions and see how these people ask the statistics in 2019 and then statistics in 2020, so that we understand what is needed from us before we can go and write or rewrite the question paper that is going to be written next week, 15th, which is Tuesday. All right. Statistics, then we will have to go back to grade 11 to remind ourselves what we did, because it's very, very important that we touch on grade 11. Because remember, in grade 12, we only did few part of statistics, but majority of concept, they are from grade 10 and 11 under statistics. So that's why it's very important to go a little bit back and then remind ourselves what we did in grade 11. And the first one, we have to remind ourselves under measures of central tendency. So what am I referring to when I'm talking about the measures of central tendency? I'm talking about the following: the mode, the median, and the mean. So one should be able to determine these three. And then what is this mode? They are saying the mode is the common value in the data set, the value that appears most. That is the mode, right? We then move to median, which is Q2, right? We normally call it Q2. What is this? They're saying the median is the middle value in an ordered data set. Is very, very important. The order in this one is very important. Before you can be able to determine the median, the order is very important. So if you are given a ungrouped data, you first have to rearrange them and put them in ascending order. Thereafter, you can be able to determine the median. And then we go to the mean, which is the average of the data set, all right? And remember, there is a formula that we use when we are calculating the mean, which is says the mean is equals to the sum of the values in the data set all over the number of elements in the data set, all right? So that's how you should now determine what, or calculate the mean. But we are going to be calculating the mean when we start answering the questions, all right? So that we can be able to know how to do that. And then we go to 5-number summary, and then one should ask what do we have to know under 5-number summary. The first, we are referring to the minimum value, and then we go to the lower quartile, which is Q1, the median, which is Q2, and the upper quartile, which is Q3. Of course, the last one is the maximum value. And then remember, when we are referring to the minimum value, we are talking about the lowest value in the data set. And then when you go to the lower quartile, if we have to determine the lower quartile, which is Q1, is the median of the lower half of an ordered data set. This one is also important, the same with the median. Before you can determine the lower quartile, you need to rearrange the data that is given to us. Put it in the ascending order so that you can be able to see the lower quartile value. And then the median, remember I talked about the median is the middle. The median is the middle value in an ordered data set. And then the fourth one, which is upper quartile. The upper quartile is the median of the upper half of the ordered data set. So these three, they are very, very important. The order is very, very important for you to be able to get the lower quartile and the median and the upper quartile right, all right? And then the last one is the maximum value, which this one is the highest value in the data set. Then you must be able to calculate the mean. Remember, I also touched on this one. I think we'll do it practically at the later stage so that you can know how to determine or calculate the mean. And then you must be able to calculate what? The quartiles and the percentiles. And then the OGIF. This one of OGIF is the graph. So you must be able to know how to plot this graph. And sometimes this graph is going to be given to us. Then if it's given to us, we have to interpret it. You must be able to interpret the OGIF graph, right? And also this one of OGIF, we are going to have the question under it so that you can be able to understand on how do you go about the OGIF. And then be able to calculate the variance and the standard deviation with the grouped data, right? There are two ways of determining this one of standard deviation when you are given the grouped data and ungrouped data. Then I think on the later stage, I will try to explain a little bit under grouped data and ungrouped data. And then we have the symmetrical and the skewed data. Of course, the last one, which is identification of an outlier. Remember this one of identification of outlier, we have a special or specific way of calculating the outlier. We have a formula that we did. Remember this one we did in grade 11. So it's very important just to go a little bit back and then look on how do you calculate this outlier. Then now we get into grade 12 and then look what we did in grade 12. The first one, we introduced what? Regression, the regression lines, which is the line of best fit for the scatter plot, all right? Then we did what? The least squares regression line. The third one, using a calculator to determine what? Regression lines and the midpoint, okay? Now remember when we were talking about this one of regression line, we are referring to this, the equation of a straight line, right? In a form of y equals to mx plus c. But now under regression, it says y equals to a plus bx, right? A, which is the what? Is the y-intercept, while b is the gradient of that particular line. And then now we have to be able to determine the mean point, all right? And then these two, which is regression line, the equation, as well as the mean point, is going to help us when we have to plot the line of best fit on the scatter plot. But I'm going to explain it into details at a later stage so that you can be able, because this question, you can check in majority of question paper or previous question paper. They like to ask this question of regression line or to determine that equation in the form of y equals to a plus bx. The same with the midpoint. It's very, very important. And then now we go to the correlation coefficient. It's also important. And then the last one, the notes on what? On regression lines. So this are the concept that needs to be revised thoroughly so that you can prepare ourselves for the question paper that you're going to write next week on the 15th. All right. Now, remember earlier on I tried to explain the issue around the ungrouped data and the grouped data. Now let's first focus under ungrouped data. Now the first one, the most important under ungrouped data is we say always arrange the data in the ascending order. That's the first one, so that you can be able to calculate that 5-number summary. You remember we talked about the maximum, we talked about what? The lower quartile, the median, the upper quartile, the last one, we also talk about the maximum value. So in order to determine those, we need to make sure that we rearrange our data in a ascending order. The second bullet, measures of central tendency. Remember we touched on that one. We are referring to the mean, the median, and the mode. And then of course, I did explain the formula for the mean. We said it's the sum of all the items divided by the total number of items. And then the median is the central or the middle figure. For instance, for odd numbers of items, the median is the value of the what? Of the item in the middle, and its position can be calculated by using the following formula, which is n plus 1 all over 2. And then we go to this one that says for even numbers of items, the median is the mean value of the two middle items. And then the fifth bullet, it says the mode is the most frequent value in the data set. And then the sixth one is the measure of the dispersion of, or the measure of dispersion are the range, the interquartile range, and the last one, which is the standard deviation and variance. Remember, we talked about this one of standard deviation and variance. And then remember the range. Let me just touch under the range. Remember, how do we determine the range? When you have to determine the range, you say the range is equals to the maximum value minus the minimum value. Because we have touched under 5-number summary, we talked about the minimum value on how do we determine the minimum value, how do we determine the maximum value. So if we can be able to determine those, then you can be able to determine what? The range. Now, this one of interquartile range, remember interquartile range, for you to be able to determine that, you are going to say Q3 minus Q1. What is Q3? We said Q3 is upper quartile range, and then Q2 we said is what? Q1 we said is lower quartile. So it means for you to be able to determine the interquartile range, we say Q3 minus Q1. Then it gives us what? The interquartile range. And then this one of 5-number summary we talked about, and then the second from the last, we say always draw a number line when drawing a box and whisker diagram. And the last one, distribution of data does not always imply the skewed end, but it has to be supported by a statement involving what? The mean or the median. And then we go to the grouped data. Under grouped data, we'll have to focus on what? The midpoint of the class interval is used to raw the data. So this one of class interval is very, very important under grouped data. I think we are going to have a question where we have a grouped data, then I will explain around this one of class intervals. And then the frequency as well. What does it mean under grouped data? The frequency is very important. And then the third bullet, it says always when we are drawing what? The ogive. Remember, I talked about that graph of ogive, where you have to determine the accumulative frequency. And then we say the group the first lower limit and use the upper limits to plot what? The frequency. The accumulative frequency and the freehand for points joining. So after plotting those points, you are advised not to join. You are not going to use a ruler to join all those points, but we are going to be using what? The freehand, so that it can give you what? A nice S, because that shape is it's always a nice S, not using a ruler where you are going to be joining all those points, because it's not going to give you that graph, which we call it on ogive. And then the position of what? Of the median. Remember, this one now is a grouped data. So the way we used to calculate the median when we have ungrouped data is not the same. Now in this one, we are going to be using this formula. If you are given what? A grouped data. The position of the median is equals to n. It's n over 2. And then the position of the lower quartile is equals to n over 4. The position of the upper quartile, we say, is equals to 3n over 4. That's where this one is when you are given what? When we are given the ogive graph, and then we have to interpret it. And then under interpretation, surely they will ask you to determine what? The median, or the position of the median, position of the lower quartile, as well as the upper quartile. So these are the formula that we normally use when we have to determine the median or the lower, and the last one is the upper. All right, now I'm going to be starting with question 1 for paper of 2019 November exam, which is paper 2. Now let us look into this question paper. Question 1, what was the scenario? And then the scenario which is given to us, it says the table below shows the monthly income in rents of 6 different people and the amount in rents that each person spends on the monthly repayment of a motor vehicle. Now you can see the table. The first, we have what? The monthly income in rents, which is this one of 9,000, 13,500, 15,000, 16,500, 17,000, and the last one, which is 20,000. And then now the monthly payment or repayment in rent, this person will pay what? 2,000, 3,000, 3,500, 5,200, 5,500, and the last one is 6,000. And now let's first try to answer the question based on the given information. The 1.1, the first question was saying to us, determine the equation of the least square regression line for the data. Remember, we talked about this one of the least square regression line. Now let's see on how do we answer this question. 1.1. Now first, we'll have to use the calculator, and then we have that procedure when we have to determine that equation of a regression line is very, very important. Now first, what we're going to do, I believe that by now you must be able to know how to use the calculator to determine that equation, because you'll have to set the question, the calculator. You first press your mode on your calculator, and then after pressing the mode in your calculator, you press 2, which is the start, all right? And then the next step, you press 2 again. Then you'll have 2 columns, the one of X and the other one with Y. So this one of X, you then going to put what? All the values that you see on this table under monthly income, which is 9,000, 13,500, 15,000. So you're going to put everything under what? Under X, all right? Thereafter, you then move to the next column, and then the next column you will find what? Y. So you are going to put what? The monthly repayment. Then you're going to start with 2,000. You then go to 3,000 until the last monthly repayment, which is 6,000. After putting all this data, you then press what? You then press AC on your calculator. After pressing AC on your calculator, you press Shift. After pressing Shift on your calculator, you press 1. Then after pressing 1, you will see there is number 1 is type, number 2 is data, number 3 is sum, number 4 is variance, and then number 5 is what? Regression line. So you just press 5, then it's going to give you the value of A, and then it's also having the value of B. So if you are in need of value of A, you press that number. Which number is this? It's number 1, because that's where you find A. You press A, then you say equal sign. Then after doing that, then you will find this value, which is saying negative and 1,946,88. You write that value there. And then you go to B. Now to get B again, remember you start that procedure, Shift 1, then you press 5, and then you press 2 for the value of b. Then it's going to give us what? 0.41. And thereafter, remember the formula for that regression line is y equals to a plus bx. Then the value of a, you just substitute the value of a there, which is negative 1946.88, plus b, the value of b is 0.41x. Then we have answered that question, right? The next question, it says 1.2. If a person earns 14,000 per month, predict the monthly repayment that the person could make towards a motor vehicle. Now, this person is now earning what? 14,000 per month. So we need to predict the monthly repayment. Now, since we've got the formula based on the data which is given, it's going to be easy for us to calculate that. Now, let's see on how do we do that. You write the formula. Now, remember, when we talk about the monthly income is the X values. Let me just show you something here. This one, it represents the X values, and then this one represents what? The Y values. Hence, you see that in a place of X, we now substitute what? The 14,000, because it's what? It's monthly income, is the earning. So this person earns 14,000 per month. So hence we substitute that 14,000 where you see X, so that we can be able to determine what? The monthly repayment, all right? Then after substituting with 14,000, you just press your calculator, then approximately is going to give us what? 3,793.12. So this is the value that we are looking for. So that prediction, it gives us the monthly repayment of 3,793.12 cents. All right. Then we go to 1.3. 1.3, it says determine the correlation. It's very important, this one. Determine the correlation coefficient between the monthly income and the monthly repayment of what? Of motor vehicle. Now, this 1.3, to answer it is very, very simple. Remember earlier on, when we were answering 1.1, we had to put everything on the calculator, the data that is given. Then, for you to be able to determine this correlation value, you go again on your calculator. You don't have to put again this data which is given to us. You go to your calculator, because the data is still on the calculator, or the information is still there. You just press your calculator, you press Shift 1, then you press what? You go to 5, then where you see R, and then in this calculator you can see it's number 3. You press 3, then equal sign. Then it's going to give us the value of R as what? 0.946. All right. Then writing how many numbers after comma is very important. Remember, in every question paper there is instructions, and then there is this as a very important instruction that which number you should write after comma. All right. So you should always follow that instruction of how many digits we should write after comma. It's very, very important. I think we have answered the whole questions, and then we can proceed. And the question is still continue. We still have other questions on question 1, paper 2 of 2019. We still having the same scenario, but now with a new question, which is 1.4. This question says, a person who earns 18,000 per month has to decide whether to spend 9,000 as a monthly repayment of a vehicle, of a motor vehicle, or not. If the above information is true, representation of the population data, which of the following will be will the person mostly likely to decide on? Meaning we have to choose between A, B, C, D, based on the scenario which is given to us. Remember, this person now is earning 18,000 per month and deciding whether to spend this 9,000 as a monthly repayment of a vehicle, a motor vehicle. Now let's first read the first statement. A, spend 9,000 per month because there is a very strong positive correlation between the amount and the monthly repayment. Remember earlier on, we determined what the correlation, and that value of R, it was 0.9. If you remember, it was 0.945. All right. And then remember, we have that list of the correlation. If zero, what is the correlation? What does it say? If it's 0.5, what does correlation say? Now, since we have determined on this question, we have determined 0.945 as our correlation. Now, this statement, which is A, it says spend 9,000. Is this person have to spend 9,000 per month because there is a very strong positive correlation between the amount and the monthly payment? I think this one statement is going to be out, all right? But I will explain why it's out. Because when you draw that line, which is a regression line or the best fit, this point, which is 18,000 and 9,000, is going to be far from that line, all right? It's going to be far from that line. So surely we cannot say it's a very strong positive, because it only be very strong positive if this point is going to be near the line of line best fit, all right? And now we go to number 2, meaning A is out. B, it says not to spend 9,000 per month because there is a very weak positive correlation between the amount and the amount repaid. It cannot be very weak positive because the value of R, which we have determined, it was 0.9 what? 0.945. So if 0.945, it cannot be very weak positive. So meaning this one is also out due to this statement, which says very weak positive correlation. It's not a very weak positive correlation based on the value that we have determined. And then C, spend 9,000 per month because the point, which is 18,000 is to 9,000, lies very near to the least square regression line, which is false. Which is false. This one, 18,000 is to 9,000, we can call it an outlier. It's very far from that line, right? Because if you can check these values here, we have 9,000, 13,000, 18, and 20,000. This one is say 18,000 is still fine, but look at this one of 9,000, and then look under monthly repayment. We have 2,000, and the highest value there is 6,000, and then now suddenly is going to have what? 9,000. You can see this when we have to plot this point on the scatter plot. It's going to be a point away from that line, which we call it the line best fit. All right. So it cannot be near that line, which is a least square regression line. The last point, which says not to spend 9,000 per month because the point of 18,000 is to 9,000 lies very far from the least square regression, which is correct. Which is correct. Because if you can plot this one, you'll notice that this point is going to be away from that line. And once it's away from that line, then the person must not be able to spend this 9,000 per month. Hence, our solution in this case is D. So if you have to answer this question, it's fine. You can just write the whole statement, or you can just write D. You're still going to get the whole marks, right? I think we are done with question 1 of 2019 paper 2, and then we are now going to be answering question 1 of 2020 November exam, the question paper which was written on the 16th of last month. And then let us try to see how did they ask this question 1. All right, now let us first study our given scenario. It says a mathematics teacher was curious to establish if her learners' mathematics marks is influenced their physical science marks. In the table below, the mathematics and physical science marks of 15 learners in her class are given as percentage. You can see the first row there is mathematics in terms of percentage. Remember, we said this is X, and then now this is Y. And then this question is for 2020. And then you can compare it with that one that we just did of 2019. There is similarity there. You remember the first scenario that is given there. We had a table like this one where I have to indicate which one is X, which one is Y. Remember? Now let's see the question of this scenario. All right, the first question, learners had to determine what? They had to determine the equation of the least regression line for the data. And if you remember very well, this was the first question of 2019, question 1.1. We had to determine that equation. All right. Now, remember what I said. For you to be able to determine that equation, you first have to press your calculator. The first step, you press mode on your calculator. After pressing the mode, you then press 2 on your calculator. After pressing 2, you press 2 again. Then it's going to give you 2 columns. The first column is going to be the X values, and the second column is Y values. So under X, you know what to put. You are going to put this one, this marks of mathematics, which is 26, 62, 21, 23. Under X, then you then move to the next column, then you then put the physical science marks, which is 34, 67, 28. And then make sure when you press all these values on your calculator, take your time, make sure you don't miss any value there, because once you miss any value there, there are chances that you are going to get every question wrong, because now most of question they are going to be depending on this equation that we have determined in point 1.1. All right. Then after doing that, after putting everything on your calculator, you press equal sign, and then you then press AC. After pressing your AC, you press shift. After pressing shift, you go to Y, you press 1. That is going to give you the information there. And then you only go to what? To number 5. That says regression line, because we are looking for that. Then you press 5, right? And then let's see what is going to be the value of A. In this case, the value of A was 9.5. In the value of B, it was 0.91, right? Then you write the formula, which is Y equals to A plus BX. Then you then substitute the values of A, which is 9.5. And the value of B is going to give us 0.91x. So that is the equation that we are looking for. So we are going to get the full marks. Now, the next question, 1.2. Draw the least squares regression line on the scatter plot provided in the answer book. Now, for you to be able to plot that line, remember it's a straight line. And this equation is the equation of a straight line. Now, let's see on how best can we draw that line. First, you need to determine the mean. Now, for you to be able to determine the mean, you don't have to start afresh putting all the data that is given to us, all right? Because everything is already on your calculator. You go to Shift, then you press 1. After pressing 1, this time you are going to press 4. Then you will see the line X there. You're going to see something like this on your calculator. You press that value, which is 2, then equal sign. There's going to give us this value of 45,1. Thereafter, then we're looking for this one where you see Y, and then you go to a calculator, you press what? Shift 1, 4, and then you will see line Y there. After seeing that line Y, you then press 5 because it is on number 5. Then you say equal sign, then it's going to give us this value of what? 50,5. Thereafter, because we have determined the equation on 1.1 of that line, and then we are going to be looking at what? Y-intercept. Now, remember when we are looking at Y-intercept from this equation which we have determined, you are going to let x to be 0. Then if you let x to be 0, what is going to happen? This is going to give us what? The value of I is going to be 9,5. Hence, we are having that point of 0 is to 9,5. So these two, which is the midpoint and the y-intercept, is going to help us to be able to draw that line. All right, let's see. This is the solution. This is the least square regression line that we had to plot. All right, this is the line. Now, I just want to explain the first point, which is this one of y-intercept 0 is to 9,5. Then that point is just here. So you're going to plot that line here. All right. After plotting that point of y-intercept, you then plot this one of midpoint, which is 45,1 is to 50,5. Then I think, remember the x value there is 45. So 45 is going to be somewhere here. It's going to be somewhere here, 45. And then it's going to be, you take a line, then it's going to give us that 45,1. And then the y value there is 50,5, which is approximately on this one, which is this point here. You can see that point is there, the midpoint. Then after we have determined the y-intercept point and the midpoint, you just join those 2 points. Then it's going to give us what? That line that we are looking for, which is least square regression line. So you'll only be able to plot that line if you have what? If you have the midpoint and as well as the y-intercept. It's very, very important, because after plotting all these points, remember, you don't join those points. You don't, all right? But you have to plot what? The best line fit, which is, they call it a least squares regression line. Now, for you to be able, I repeat, for you to be able to plot this straight line, you first have to determine what? The y-intercept. And I've just explained to you on how do we determine the y-intercept. You let x to be 0 on the equation, which we have determined on 1.1. So if you put 0 here where you see x, surely we are going to be left with 9.5. That is going to be the y value. That point is going to be 0 is to 9,5. That's number 1. Number 2, the midpoint. The midpoint, you're also going to be getting those values where? From your calculator. Remember, you have put everything when you are determining the equation. You just go to your calculator, because everything is still on the calculator. You press shift, you press 1. After press 1, you then press 4. Then you will see there is a line X there, there is line Y there. So where you see X, you press that value, then equal sign. Then it's going to give us what? It's going to give you 45,1, and then the other one is going to give us 50,5. Then you can be able to plot that line. All right. Let's proceed. The question still continue. We are still on question 1, paper 2, 2020. Right, same scenario. Now we have a new question now. 1.3, it says predict the physical science mark of a learner who achieves 69% for mathematics. You remember when we were dealing with question 1 of 2019, there was a question, but remember we were talking about the monthly income. This person was earning 14,000, and we had to predict about the monthly repayment. And then what did we use? We used what? The formula that we have determined after putting the information which was given to us. All right. Now the same applies with this one. We're going to do the same. Now in this case, in this one, they say we should predict the physical science mark if a learner who obtained 69% for mathematics. Now let's see on how do we go about this one. And remember, we have determined the equation. Now I indicated to you earlier on that this is X. Remember, this is Y. Now, what is this 69% for maths? I think that one is X, meaning where you see X, then you're going to be substituting with what? 69%, so that you can be able to determine or predict the physical science mark for that particular learner. Let's see, where you see X, you just substitute with 69, you press your calculator, then it's going to give us a physical science mark as 72.29%. All right, that's how you should answer this question. And then 1.4, 1.4, write down the correlation coefficient between the mathematics and physical science marks for the data. Now remember the correlation coefficient, the value of R. All right. So even this one, you don't have to stress yourself, try to do things. Remember, in your calculator, you have everything in your calculator. For you to get the value of R, you don't have to put again the information which is given to us. You go to a calculator, you press Shift 1, then 5, then you will see there is R there. So you press that value where R is, which is 3 in this case, then you press 3, then equal sign, then it's going to give us the value of R. Now in this case, they say the value of R equals to 0.95. All right. 1.5, comment on the strength of the correlation. Comment on the strength of the correlation between the mathematics and the physical science marks for the data. So in every textbook, I think that we are using, there is those list of different types of correlations. So it will tell you if it's 0, if the value of R is 0, what is the strength? If it's 0.5, what is the strength? If it's 0.95, what is the strength? So you just have to study that table so that you can be able to answer this question of 1.5. Let's see. They are saying there is a very strong positive correlation. Even if you can just write strong positive, you are going to get the full marks. You just write very strong positive. This is what we want to see. If a learner have to comment on this one, we have to see very strong positive. Then we are going to give you full marks. All right. And then the last question, which is 1.6, what trend did the teacher observe between the results of the two subjects? The teacher includes that the higher the learner mathematics marks, then automatically the higher the learner's physical science marks. Meaning you can even see from this table here, look at this learner here. The learner got what? 76%. Look at physical science. It's also 76. And then a learner who got 85 in mathematics, then in physical science, you can see a learner is performing very well in physical science. All right. So that's, I think, the trend about this information which is given to us. So if a learner is performing in mathematics, automatically that then is going to perform very well in physical science. That's what we have discovered on this question. We are now getting to question 2 for 2019 November paper. All right. The scenario says a survey was conducted amongst 100 people about the amount that they paid on a monthly basis for their cell phone contracts. The person carrying out the survey calculated the estimated mean to be what? We're now having the mean, which is 209 Rand per month. Unfortunately, he lost some of the data thereafter. The partial results of the survey are shown in the frequency table below. You can see we have what? The interval. Remember earlier on I did explain around the interval. This is the interval. The amount paid between 0 to 100, it's how many frequency. What does 7 mean? The number of people. All right? The number of people, it means 7 people. People who paid from 100 to 200 is 12 people. And then there we have unknown, which I think we are going to have to determine the value of A. And then of course this one of 3, between 300 to 400 is 35. Between 400 to 500 is B. Also this one we will have to determine the value of B. And then the last one is 500 and 600. It's 6 people. But all in all, when you add the number of people based on the survey is 100 people. All right, that is the total number of frequency. Now the first question, let's see the first question. How many people paid 200 or less on their monthly cell phone contract? Listen, let me read the question again. How many people paid 200 or less? All right, then when you go to this table, you'll see we have a 200 here and we also have 200 here. All right, but now listen to this one. It should be 200 or less. And then when you read from this table, it says X is less or equals to 200, meaning we start from this one, then we say less. So it is from 200 and less, meaning it's from 0 Rand to 200 Rand. So we need those people. How many are they? We are going to say it's 12 plus 7. Then it's going to give us the total number of those people, which is going to give us 19 people. The number of people paid 200 or less is equals to 19 people. All right. The next question, use the information above to show that the value of A is 24 and the value of B is 16. Let's first see. Now, from the scenario, remember we are given what? The estimated mean, which was 309. Now, remember, if you are given a table like this one and we have to determine the mean, this is the formula that we have to use, which is what? The sum of frequency multiplied by what? The midpoint, because X is then for what? The midpoint. The midpoint of what? Of this one, of the interval. So how are we going to determine the midpoint? You're going to say 0 plus 100 divided by 2. Then it's going to give us the midpoint. And then the second one, you say 100 plus 200 divided by 2. It gives us the midpoint. That's how you should determine that value of x. Now, of course, F stands for what? It stands for frequency. So you can see this one is F multiplied by x. F is the frequency, x is the midpoint. And then I've just explained to you how do you determine this midpoint. You say again 0 plus 100 divided by 2, then it's going to give us 50. That 50 is what? Is the midpoint. Then you can see this one. Remember that this symbol, it symbolizes what? The sum, meaning the sum of what? The sum of frequency multiplied by the midpoint. All right? Then it's going to help us to be able to determine the value of A and B. Let's proceed. Now, first, remember, if you add all this frequency, all this, the sum should give us what? 100, because remember, the survey was conducted amongst only 100 people. And I also indicated to you that frequency is referring to the number of people, all right? This 7 is 7 people, 12 is 12 people, 35 is 35 people. So when you add all those people, they must give us what? 100, because the survey was conducted amongst those 100 people only. Hence, we say we add everything and then equals to 100. All right. But remember, we have two unknowns or two variables, which is A and B, and we are in need of those two. Then the second step, what you do, since we have two unknown variables, then what I did here, I make A the subject of the formula, meaning instead of A, I have A equals to 40 minus B. All right. I make A the subject of the formula. You can also make B the subject of the formula, all right? But in this case, what we did is A the subject of the formula. Then when you proceed, remember, the mean is given to us from the scenario. It was 309, which is this one, all right? And then the formula, it says the sum of frequency multiplied by the midpoint. Now, remember 50, where does 50 come from? We said 0 plus 100 divided by 2, it gives us 50, multiplied by this 7 is what? Is what? This 7 is the frequency, and this frequency here is 7, right? Let me just remove this one so that you can be able to see. All right. This 7 multiplied by the midpoint of this one, of this interval, plus 150, 100 plus 200 divided by 2, it gives us 150, multiplied by 12, plus, then you also do the same with this one, 200 plus 300 divided by 2, multiplied by the frequency, in this one is A, plus 350, where do we obtain 350? We say 300 plus 400 divided by 2, multiplied by the frequency, which is 35, all right? Then you do the same with this one until you reach to the last step, which is 500 plus 600 divided by 2, it gives us 550, multiplied by the frequency, which is 6. Divide by what? Divide by the sum of frequency. Now this is what? This is the sum of frequency. What is the sum of frequency? Remember, I indicated it's 100. That is the total number of people, which is divided by the sum of frequency. Thereafter, the second step, since, let me just remove this one so that you can be able to see clearly. All right. Remember earlier on, I did make A the subject of the formula, meaning where I see A, then I'm going to substitute this 40 minus B. Now remember on this one, I had A. Now instead of A, I substitute with what? I substitute A with 40 minus B, so that I can have the same variable. Then I can be able to determine that the value of that particular variable. Thereafter, I open the bracket. After opening the bracket, this is what I'm going to have. Then remember, this is going to be cross multiply. If you cross multiply, you're going to say 309 multiplied by 100, then it's going to give us this 30,900. Then here you just multiply everything, you open your brackets, then this is going to have, you're going to have this one and this one. Thereafter, you're going to say, because we're having the like terms, then it's going to, you're going to say negative 250b plus 450b. Let's see how much you have. It gives us 200b equals to what? Equals to 3,200. Now remember this one of 3,200. How do you obtain? You add all these values and then you transpose that value, and then you're going to minus it from this 30,900. Then it's going to give you what? 3,200. Thereafter, because we're in need of b, then you're going to divide both sides with 200. Then it's going to give us b as 16. Then we have determined that 16 there. Then for you to be able to get this 24 as the value of a, remember already on this one we have we make a the subject. So where you see b, you just substitute this 16. So it's going to be 40 minus 16, and then it's going to give us what? 24 as the value of a. All right, it's quite simple. Now let's proceed. The question still continue. We still have the same scenario there, but we have to answer a new question. 2.3. Write down the model class for the data. Let's see how do we determine that. Now, if you are dealing with the model class, and then now it is in the grouped data like this one, then how do we determine that? You just go straight to the frequency values. Any frequency which is greater others, then that's where we're going to determine what the model class. Hence we say is between 300 and 400, because the highest frequency there is 35. So we just take the highest value of frequency that is going to help us to determine what the model class interval. And then 2.4, on the grid provided in the answer book, draw the OGIF graph. Then we have to draw the graph. Now this is the graph that we have to draw. So remember earlier on I did explain to you that when after plotting these points, every point, you then have to use a ruler to join all these points. You use your free hands, you just make a nice curve like this one, and it's very simple, because you'll have to complete this table where you have to get the accumulative frequency first, right? Then how do we determine the accumulated frequency? If I just have to remind you, first we are going to start with 7, because we're going to expand this to have another column here. You have to get another column there, like this one. Then you say 7, this is 7, then you say 7 plus 12, then you add it here, you write the value there, then from there, you say that value plus the value of a, then you write it there until you complete this column there. That is going to give us the value of y, which is accumulative frequency. Thereafter, you plot all those points, and then you join them with a free hand. Then you are going to have what? The OGIF graph. Then 2.5, determine how many people paid more than 420 per month for their cell phone contract. Then they say the number of people is 100 minus 82, which is 18 people. Now, how do you obtain this one? Because we're having what? 420. Then you go to your graph, and then when you look on the x-axis, we have 400 there, and then you're going to say 410, 420. Then from here, you are going to draw a vertical line upwards until you reach to the graph. Then after touching the graph, then you take this line to the left to the y-axis, all right? Then approximately is going to give us 80, 81, 82. So any value between 80 to 80 what? To 84 is acceptable, all right? Thereafter, then we say, because we want the number of people paid more than 420, meaning from here, this portion here are people who paid more than 420, all right? 420 per month. Meaning we also have to look how many people are on this portion. So we are going to do what? We're going to say 100 minus 82, then it gives us what? 18 people, all right? But this one is going to differ because it's not 100%. We are not 100% correct, but at least a learner must be able to get between 80 to 84. So some learner they will say 100 minus 80, still acceptable. Some they will say 100 minus 82, 83, 84, still acceptable, all right? And then now we go to the last part of 2020, question 2. And then let's look into this one. We're having a scenario and the diagram there. And then it says the number of aircraft landing at the Kinshasa International Airport and the Port Elizabeth Airport for the period of starting in April 2017 and ending in March 2018. It's shown in the double bar graph below. You can see here that is the information we have for the Kinshasa International Airport as well as what? As well as the Port Elizabeth, all right? From April to March 2017 to 2018. Uh, 2.1, it says the number of aircraft landing at the Port Elizabeth Airport exceeds the number of aircraft landing at the Kinshasa International Airport during the sum month of the given period. During which month is this difference the greatest? Let's see. That month is what? Is July, all right? You can see July is this one, where there was a great landing on Port Elizabeth Airport than Kinshasa. You can see the Kinshasa is this, the black bar, and this one, the gray one, is for what? Is for Port Elizabeth, all right? So hence we have taken this one this month, which is July. Now the number 2.2, the number of aircraft landing at the Kinshasa International during this month are, we have the data there. Then the first question, we should calculate what? The mean of the data set. Now, how do we determine the mean? Remember, I did explain to you earlier on the formula that we use to calculate the mean. We said to you that the mean is equals to the sum of the values in the data set. These are the values. You add every value that you see on this table, divide by the number of elements in the data set. You check how many are there. You can count them. I think there are 12, 2, 4, 6, 8, 10, 12. Then hence we divide with 12. So after adding, we have obtained 26,941 divided by 12. Then the mean that we are having there is 2,245,1, the aircraft landing. So that's how you should determine what? The mean. The question still continue. We have the same scenario, and then we have a new question. 2.3, calculate the standard deviation of the number of craft landing at the Kinshasa International Airport for the given period. So you remember the data that is given to us. Now this is a standard deviation for the landing at the Kinshasa International Airport. All right. And then 2.4, determine the number of months in which the number of aircraft landing at the Kinshasa International Airport were within one standard deviation. One standard deviation is very, very important. Now let's proceed. Now first, for us to be able to determine the total number of months, we are going to say, remember this, then for the mean minus what? The standard deviation. So it's going to be the mean minus the standard deviation. What is the mean? Remember earlier on we have determined the mean. Our mean, it was 2,245,08 minus the standard deviation. Remember the standard deviation in this case is 86,3. Then we say the mean again plus the standard deviation. This is what we have. Then from there you minus and you add them together. Then they give us what? After subtracting the mean together with the standard deviation, it gives us 2,158,78. After adding the mean as well as the standard deviation, it gives us 2,331,85. Now, so we are going to count how many months. So in order to determine how many months, you check anything, any number which it falls under this interval from 2,158,78 and 2,331,8. We are going to count it. So anything which is not within this interval, we are going to cut it out. Now, you can see this value here is below what? Is below 2,158. So meaning we are going to take it out. All right. And then we have another one which is greater. This one here. So this one is also greater, 2,331. And also this one is greater, 2,331. All right. Now, everything you can see now, it falls within this interval. So we should count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then that is going to give us the answer, which is there are 9 months when the aircraft arrived at the Kinshasa International Airport were within 1 standard deviation of the mean. So that's how you should now determine this question, or how many months that we are looking for. I think we're at the last stage of this question. All right, the last question. Remember, we have the same scenario there. We are now having a new question. 2.5, it was saying which one of the following statement is correct? Which one of the following statement is correct? 1, A, because we have to choose between A, B, C. Which one is correct? Let's start with the first statement. During December and January. Let's look at December. Yes, December and January. There are more landing at Port Elizabeth Airport than at the Kinshasa International Airport. Let's look into that. The darker bar is for Port Elizabeth. Now this one is out. It's incorrect. This one is incorrect. All right. Now, B, there was a greater variance in the number of aircraft landing at the Kinshasa International Airport than at the Port Elizabeth Airport for the given period. Let's check into this one. You can see that there is more into Port Elizabeth. You can see this one is greater, this one is greater, this one is greater, this one is greater. So there is more into, there's more landing into Port Elizabeth. So this statement is going to be what? False. Now the correct number there is C, which says the standard deviation of the number of landing at the Port Elizabeth Airport will be the higher than what? The standard deviation of the number of landing at the Kinshasa International. You can see that if you compare the Port Elizabeth together with Kinshasa there, you can see the more landing it was on what? On this Port Elizabeth Airport, all right? So hence we say the standard deviation of the number of landing at Port Elizabeth Airport will be higher than what? The standard deviation of what? Of the landing at Kinshasa International Airport. So that statement is correct. All right. Thank you very much for being with me on this interesting lesson. I hope everything that I've touched is going to help you when you are revising for paper 2 for mathematics. Let me just leave you with words that says never give up. Today is harder, tomorrow will be worse, but the day after tomorrow will be sunshine. Thank you very much. Have a blessed day. Bye.